Topic: Triangles. Learning area: Similar figures and similarity of triangles. Do you have any idea about basic proportionality theorem? To get an idea of what basic proportionality theorem is, let us perform the following activity. Draw a line segment AB of length 7 centimeters. At A, draw a ray AP making an acute angle. From A, make 7 equal parts on the ray AP and name them as A1, A2, A3, A4, A5, A6 and A7. Join A7 and B. Draw a line at A4 parallel to the line segment A7B, meeting the line segment AB at C. Measure the line segment AC. It is equal to 4 centimeters, and measure the line segment CB. It is equal to 3 centimeters. Therefore, the ratio AC is to CB is 4:3. What do we infer from this activity? If we consider A7B as a triangle, then A4C is a line that is parallel to the side A7B. We found that the line segment A4C divided the sides AA7 and AB in the same ratio, that is 4:3. The above activity will give us an idea about the basic proportionality theorem. Basic proportionality theorem is applied in many fields. Particularly, it is used in determining the equivalent resistance, capacitance and inductance via graphical approach in the field of physics. At the end of this lesson, the students will be able to state the characteristics of similar figures, determine whether two given polygons or figures are similar, prove the basic proportionality theorem and solve problems based on it, prove converse of basic proportionality theorem and solve problems based on it. Observe these figures. What do you infer from your observation? These pictures look alike but are not of the same size, aren't they? Such set of figures are called similar figures. How shall we define similar figures? Similar figures have the same shape, but their sizes may or may not be the same. Now, consider any two or more circles. Are they congruent? Since all of them do not have the same radius, they are not congruent to each other. Note that some are congruent and some are not, but all of them have the same shape. So, they are called similar. Two similar figures have the same shape but not necessarily the same size. Therefore, all circles are similar. What about two or more squares or two or more equilateral triangles? As observed in the case of circles, here also all squares are similar and all equilateral triangles are similar. From the above, we can say that all congruent figures are similar, but the similar figures need not be congruent. What can you say about the two quadrilaterals ABCD and PQRS? Are they similar? These figures appear to be similar, but we cannot be certain about it. Therefore, we must have some definition of similarity of figures, and based on this definition, some rules to decide whether the two given figures are similar or not. Two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. Basic proportionality theorem or Thales theorem. If a straight line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides the two sides in the same ratio. Given that in a triangle ABC, a straight line L parallel to BC intersects AB at D and AC at E. To prove that AD by DB is equal to AE by EC. Point BE, CD. Draw EF perpendicular to AB and DG perpendicular to CA. Let us prove now. Since EF is perpendicular to AB, EF is the height of triangles ADE and DBE. Area of triangle ADE is equal to half times base times height, which is 1 by 2 times AD times EF. Area of triangle DBE is equal to half times base times height, which is 1 by 2 times DB times EF. Therefore, area of triangle ADE by area of triangle DBE is equal to AD by DB. Since DG is perpendicular to AC, DG is the height of triangles ADE and DCE. Area of triangle ADE is equal to half times base times height, which is 1 by 2 times AE times DG. Area of triangle DCE is equal to half times base times height, which is 1 by 2 times EC times DG. Therefore, area of triangle ADE by area of triangle DCE is equal to AE by EC. Now let us see a few problems based on basic proportionality theorem. In the given figure, ABC is a triangle in which DE is parallel to BC. Find the value of X using basic proportionality theorem. Since DE is parallel to BC, by basic proportionality theorem, the ratio of the line segments AD to DE is equal to the ratio of line segments AE to EC. Since the values of AD, DB and EC are given, substituting these values in the ratio, we get X is equal to 9. Let us see the converse of basic proportionality theorem. Given that a line L intersects the sides AB and AC of TABC respectively at D and E such that AD by DB is equal to AE by EC. To prove that DE is parallel to BC, construction if DE is not parallel to proof. Since DF is parallel to BC, by Thales theorem, we get AD by DB is equal to AF by FC. From equations 1 and 2, we get AF by FC is equal to AE by EC. adding 1 on both sides and simplifying, we get AF plus FC by FC is equal to AE plus EC by EC. Now, AC by FC is equal to AC by EC. Thus, FC is equal to EC. This is possible only when F and E coincide. Therefore, DE is parallel to DC. Thus, converse of basic proportionality theorem is true. Let us look at a few problems based on the converse of basic proportionality theorem. In the figure given below, verify whether DE is parallel to BC or not. In the given triangle ABC, AD by DB is equal to 2.5 by 7.5, which is equal to 1 by 3, and similarly AE by DE is equal to 3.2 by 9.6, which is also equal to 1 by 3. Therefore, the ratio AD by DB is equal to the ratio AE by EC. Hence, by the converse of basic proportionality theorem, DE is parallel to BC.